Hello guys, this is the sixth problem from the TIFR series, TIFR-GS 2010 section A. So this is a nuclear physics question. It says that we have a lead container containing a gram of cobalt-60 radioactive, and cobalt-60 emits a beta particle of energy 316 kilo electron volt, followed by 2 gamma emissions of respective energies. So which of the following experimental methods would be best to determine the lifetime of this radioactive source? Now best way is also, you can say that the cost effective way or the fastest way, like that. So the first option is measure the change in temperature of the source. So definitely that is not something that we use to measure the lifetime. We know the basic formula that we once use is T half, that is half-life of a radioactive particle is equals to uh, 0.693, which is also a constant by lambda, right? So lambda is the decay constant, and so T half is dependent on lambda. So if we have to find the lifetime, we need to know the decay constant. Decay constant is again related like n is equals to n0 e to the power minus lambda t. So when t equals to T half, your n will become n0 by 2, like that. N0 is the ordinary number, initial number of particles, and capital N is the number of particles at time t. So here we are dealing with number of particles. Decay constant is a constant, we don't need to think about that. So we have to find number of particles, so not role of temperature here. So the first option can be cancelled, right? So let us cancel this. Now the second option is measure the weight of the source now and again after 1 year. So this looks like it could be a good way to find the lifetime of the CO cobalt-60 source, because if we are fixing a time, then we can find the decay constant. So if you say T is equals to 1 year or 365 days, right? Now what you can do is you can find the decay constant. So after 1 year you measure the number of particles, so you will get n. Now you have already n0, that is you can find 1 gram of cobalt is given. So from there you have Avogadro number by weight, like that, find the number of moles, so you get n0, and the only unknown term is lambda. So you will get lambda like that. If you get lambda, then you can easily get T half, which is the half-life, and if you get half-life, multiply by 2, you will get total lifetime. So this is the correct option as it looks for now. Let us check for some other options and see what they are telling us. So the next option is measure the recoil momentum of the nucleus during beta emission, which is again not the ideal thing that we need to do in this experiment. We need to find the number of particles, right? So recoil momentum has no use here. Usually recoil momentum, as far my memory goes, is used in the Rutherford experiment for the finding the scattering angle or the impact parameter of the nucleus. So no use in this radioactive decay problem. You can cancel it. Now the last option is measure the number of gamma photons emitted by this source. Again, gamma photons is like, okay, gamma particle doesn't have a mass. A gamma particle only attributes to the momentum conservation of the nuclear reaction, right? So again, it's related to the momentum part, not to the number of particles necessarily here. So gamma photons emitted by this source is not really related to the number of particles decayed or conserved in the cobalt radioactive source, like that. If it was beta particle, then it could have been said that okay, beta particle has the mass of electron, so like that you can find the energy divided and energy added after a time t. But for gamma it doesn't look that way, and this is an MCQ problem, and we have already said that B is the right option. It looks like that as for now, so you can say yeah, B is the right option. And with that we conclude this nuclear physics problem. Stick around, we will upload the next problems very soon. Thank you for watching. Subscribe to the Bhautik Shastra, and share with your friends or your teachers who are into TIFR series, solving TIFR or cracking TIFR. So thank you.